Welcome to our next lesson in the Pragmatic REST APIs course, where we are going to talk about rate limiting in REST APIs. Rate limiting is a technique that allows you to control the number of requests a given API client can make to the API server. Rate limiting introduces some very tough constraints for your API consumers, but it also protects your API from malicious users, and it controls how you expend your server resources. So it's definitely valuable, and you should consider it when building a REST API. Now, when it comes to how to implement rate limiting, I will show you a built-in approach that we have in .NET, and I'm going to give you some remarks on whether or not you should be using this in production. We have 4 built-in rate limiting algorithms available in .NET, and the first one is the fixed window rate limiter. It defines a time window, let's say 1 minute, and the total number of requests that a client can make in a given time window. If we reach the permit limit in a given time window, the requests are simply aborted and we get back a 429 too many requests response. Then we have the sliding window, which is somewhat similar. It still uses a time window approach, but we split the time window into multiple segments, and inside of each segment we define what are the allowed number of requests. All these segments that belong to one window represent what are the allowed number of requests that we can make in a given window. So it's a bit more flexible than the fixed window approach, but it's also a bit more complicated to implement. Then we have the token bucket rate limiter, which is one of the simplest approaches. It simply defines a bucket which contains so-called tokens, which represent one API request. When you send an API request, you expend a token from the token bucket, and then there is a time window when the token bucket replenishes, and you can also configure how many tokens are replenished in a given time period. Lastly, we have the concurrency limiter, which is the simplest of the bunch, and it simply defines how many concurrent requests can be made for a given rate limit policy. Now let me jump into the code and show you how we can implement this. We have to do 2 things to enable rate limiting. The first one is configure the rate limiter services. So I'm going to define a method in just a moment called add rate limiting, and this is going to configure the rate limiting services and the required policies. The second thing we have to do is to introduce a rate limiting middleware. So I'll say app use rate limiter, and this will introduce the respective middleware to my request pipeline. Now we could argue where in the pipeline we want to apply a particular request. I'm going to place it after authentication and authorization because I mainly want to focus on authenticated users inside of my API. Now let's go ahead and add the add rate limiting method. Inside of the dependency injection class, I'll add this method at the bottom, and I will say public static web application builder add rate limiting. Let's make it an extension method. Let's define our builder, and I can just return my builder and my method is complete. It will be added in my program file, so I will close this down, and then let's see what we have to do here. To configure rate limiting, you just say builder services add rate limiter. Now this also accepts an options object where you can introduce additional configuration. There are a couple of helper methods that you can use right from the start. We're adding specific rate limiters. So there is the sliding window rate limiter, the concurrency limiter, the fixed window limiter, and the token bucket limiter. These are all the algorithms that I mentioned in the introduction to this lesson. Now what else can you do? You can also configure a global limiter, which is going to apply to all of your API requests, but this is something you may want to avoid for most use cases. Another thing we can do is configure what happens when the rate limit is reached. You get access to an onRejected context, which contains the current HTTP context, and this allows you to set some response headers and even write to the response body. Now here's what I want to do inside of this delegate. I'm going to use the onRejected context to try to get some metadata that I want to include in the response. And this will be the retry after value, which is a time span representing when the client can retry a request. I'm going to set this value in the retry after response header, and then I'm going to resolve the problem details factory from dependency injection using the request services on the HTTP context, and I'll use that to create my problem details instance. I can write this to the response, and this will return a standardized response to our API clients. Finally, I can define my default rate limiting policy. So here's what I'm going to configure. I'm going to say options, add policy, give it a name of default, and this gives me access to the HTTP context. I can use this to try to obtain some partition key that's going to allow me to place the users in a given partition where I can apply rate limiting. So I'm going to try to use the username of the current user, and if it's not null or empty, then I'm going to use the token bucket limiter, which is going to allow 100 requests in the token bucket. It's also going to queue any requests once we reach the limit, and the replenishment period is 1 minute. And after every minute, you're going to get 25 tokens back inside of the token bucket. So this should apply for authenticated users. Now, if the username is null or empty, then I'm going to treat this as an anonymous user, and I'm going to be very constrictive here. I'll use just one partition for all of our unauthenticated users, and I'm going to use a fixed window rate limiter here and return the permit limit of 5, and the time window is going to be 1 minute. So if somebody isn't authenticated with our API, then they can only make 5 requests per minute, and this will apply to all clients inside of our system because they will all fall into the anonymous partition. So now that we have our rate limit policy defined, how do we actually use it? Well, you have to go into your controllers and decorate the controller with the enable rate limiting attribute. Then you have to specify your rate limit policy name, and rate limiting is going to start working on the API endpoints for this controller. Let me start the application and demonstrate this. I'll send a request to fetch the collection of entries from our API, and I made sure that I am authenticated and providing an access token. So let me send this request, and we'll hit the breakpoint inside of our rate limit policy. Now I implemented it like this on purpose because the identity name value is always going to be null. We're not mapping this from the JSON Web Token, even though we are authenticated. You can see that is authenticated is set to true, and we have 8 claims present in the JSON Web Token. Now I did this because I want to hit the rate limit, so I'll end up using the fixed window rate limiter. Let me show you what that will look like. So I'll send a couple of more requests quickly, and after I reach the permit limit, which is 5 requests per minute, we're going to get back a 429 too many requests response. We're getting back a problem details that's saying too many requests. Please try again after 60 seconds. This is our time window. And if you take a look at the headers, there is also the retry after header, which contains the number of seconds for when you should retry sending this request. Now, in order for this to work properly, I can partition by the identity ID of the current user. So let me try this approach. And if I send another request to my API, I will land on this breakpoint, and this time the username isn't empty. We may consider renaming this variable to be user ID or identity ID just to be consistent, but what matters is I'm going to end up using the token bucket rate limiter. So let me press continue. We'll get a response back from the controller, and I can continue sending requests successfully until I reach the token bucket limit, which is far more permissive for authenticated users, and it allows up to 100 requests per minute. So let's rename the username to be identity ID, so it more closely describes what we are assigning as the partition key. And now I want to discuss a couple of more points. If you want to disable rate limiting, there is a respective attribute that you can use called disable rate limiting. You can decorate this on the controller or a specific endpoint, and this will turn off rate limiting for that controller or the specific endpoint. But one more thing I want to discuss, which is probably much more important, is how all of this actually works. So this rate limiting implementation works in memory. This means that if you want to scale out your REST API, you will have different rate limiters for each of your API instances, and this is something you want to avoid. So if you want to use the built-in approach, you can. However, consider moving the rate limiting into a reverse proxy. YARP is a good example, which is going to distribute incoming requests across your REST API instances, and YARP will take care of the rate limiting aspect so that you don't have to think about this in the REST API. Now, of course, this is more complex to implement as you add another component into your system, but it is also the correct approach. And in general, you don't want to be dealing with rate limiting on the application level. You really want to move that into a reverse proxy, an API gateway, and there are many cloud services that can take care of something like this. So this concludes our lesson about rate limiting. I demonstrated how you can integrate rate limiting with .NET and the built-in rate limiting policies, but I also raised the concern if this is something that you should be implementing inside your application, considering that the .NET implementation works only in memory and it won't work correctly if you scale out your API instances. In our next lesson, we're going to cover another very important topic when it comes to REST APIs, and that is idempotence and how to implement it on demand.